Hi everyone, welcome to another Simq VIT tutorial. In this video, I will show you the 5 most important features Simq VIT has to offer. We recommend these features be evaluated when designing an implant. We will also show you how you can better explore your simulation results. In order to follow along in this video, your simulation must have already been sent and the results be ready for evaluation. If you haven't yet, please watch our video on setting up your simulation and the next video about sending and retrieving your results. The features we will be discussing today are 1. Total deformation, 2. Material limits, 3. Contact regions, 4. Screw forces, 5. Equivalent strain of the bone. After the simulation is finished, we go to the Results tab. Now, you can see the selected results are presented as a list. First, we take a look at the total deformation option. You can move the model around with your secondary mouse button. With total deformation, you can see the deformation in all directions on the implant, taking into account deformation of bone, implant, and if applicable, a transplant. You can see how your mandible and your anatomical region responds under the physiological loads that you selected. With the load step animation, you can also animate your deformations. So you can see slight deformations and the change of the scale as you move through the load step with your cursor on the bottom right. You see a maximum deformation above in millimeters in the chin area where it's deforming the most. With the total deformation, you can also check if it's deforming physically and reasonably. If not, there's probably an error in the inputs of the model, so it's recommended to change the inputs and recalculate to get the desired deformation result. The maximum deformation is indicated in red, so all the areas of the geometry that are in red have a total deformation of the higher millimeter range. In addition, when you hover over your model, you'll see a small yellow sphere on the tip of your cursor. When you click on the geometry, this shows current and exact deformation values at the certain area of your contour plot. In this case, the deformation value is shown here. Second, we look at the material limit option, which is grayed out by default in this result because there's no predefined limit for a deformation. However, when we go into the option for equivalent stresses of the implant, now you see the material limit option can be applied. When the material limit is off and you are under the equivalent stresses option, you have a scale that starts at a minimum of 0 up to the implant's maximum in megapascals. Megapascal is the same as a Newton per millimeter squared. In short, this value just tells you how high the implant's material is stressed. When you toggle to apply the material limit, it automatically shows a maximum value which should not be exceeded. The material limit has been verified and validated and includes a safety margin. If the stress is below that value, it means your implant or product is safe. If it's above the limit, it will be shown in purple. It is important to observe the location and the amount above the maximum as well. Third, we take a look at the feature to toggle on Show Contact Region. We're still under equivalent stress of the implant. Material limit is toggled on, as well as smooth contours. So, we now toggle on Show Contact Regions. This gives the opening around the screws a smoother look. When contact regions are turned off, you can see that the opening around the screws is a bit more coarse. When the contact region option is toggled back on, you may have values above that maximum megapascal in the screw regions. This is due to what's called singularity in the simulation. This is a numerical error that can occur in contact regions. There's no cause for concern. They can accrue in very small spots in the screw connection area. That's why the option is there to toggle the contact regions on and off. When looking at the implant from behind, you can see that there's an area that appears slightly darker. It looks a bit stressed. We click on that and we can see the exact measurement in megapascal, so we're getting pretty close to that maximum. You can see from the load steps that the implant is taking the majority of the force on the more posterior portion of the mandible, even though the load case is on the premolar. From these results, you can change and improve upon the original design, maybe add or remove material or screws, without compromising safety and efficacy. Fourth is the option to show screw forces, which as you can see here are depicted using arrows. These arrows point in the opposite direction of the force's reaction. This feature is used to show how much force is transferred through a single screw. So for example, you have a screw which is loaded with 102.5 newtons. Then we have a screw which is loaded with 238 newtons, which is quite high but still totally fine. In this area, you see the screw is taking a lot of the force. In this case, possibly adding another screw to the design could be beneficial and maybe disperse the forces more evenly throughout. That's up to the designer, of course, who discusses the implant designs with the surgeons. You can rearrange the design and then send it again for simulation to test that new design. You can see in the front area that there's not too high of a load because again, that main force is coming from the bite on the premolar. This produces a lot of stress in the mandible in that region which is further away from the bite. One thing you want to keep in mind, we want to make sure that there's not high stress on the screws because this can lead to screw loosening and stress shielding within the bone, which can then lead to reduction in the bone density. The fifth and final option is to check the equivalent strain of the bone. Based on current literature, we know strains in the bone of above 3% could lead to a fracture. Therefore, strains greater than 3% in large areas should be avoided. This can be detected with Simq VIT. There's an option to hide the transparent bodies so you don't see the overlay of the implant anymore, and you can really see which screws are loaded most in the bone. So in this area, you see really that the screw and the surrounding bone is loaded quite high, but below the limit of strain, and it is specific to a patient's individual biomechanical needs. Then apply those transparent bodies back on for reference. Of note, with a few clicks, you can create a report for your personalized patient implant. First, click the Comments button. This opens up a window that allows you to add comments into the report for the surgeon, designers, quality management, or yourself. Make sure to close and save. Then click Create Report to save the report and add it to your files, QM system, or technical documentation folders. This is also a great feature for post-market follow-up. So to recap, the features discussed in the video today were the 5 most important features Simq VIT has to offer. These should be evaluated when designing an implant, and you can better explore your simulation results with these features. Of course, other results and features are available, but the ones discussed in the video today are especially important to achieve the best possible plan for the design of a patient-specific implant. That brings us to the end of the video. Thank you so much for watching. Have fun with the software, and if you have any questions, feel free to email us at support@simq.de. Take care and happy designing.